Here we are observing a student removing their flask from the incubator.
Go.
Notice how he's not wearing any gloves or any PPE when handling his cells, as well as in the hood, no gloves to take off the pipette, as well as almost breaking the sterile pipette and touching the tip is not good for the cells. There are multiple signs of contamination in here that are being recorded, and this flask will most likely be contaminated by the time it comes to testing for confluency. By adding the trypsin in, he's being rushful and is not being aware of his surroundings, as in blowing bubbles into his flask, which is bad for the cells that we know of.
First, I get my flask of cells out of the incubator. I check my confluency under the microscope, ensuring that I have at least 70% confluency in my flask before continuing. Then I start the procedure, removing the cap from my flask and attaching a new and clean sterile pipette to my gun. I remove every drop of media from my flask and place it into the waste container, making sure to put my pipette tip at the bottom corner of the flask to get all the fluid out. I grab a new sterile pipette, attach it to my gun, and add 1 ml of trypsin to my flask. The trypsin is going to break the bonds holding the cells to the flask and allow the cells to rise. I make sure all the trypsin is covering the bottom plate of the flask. I go under the microscope and see that the cells have risen. Next, I'm going to add 3 mLs of media to deactivate the trypsin. I grab a new sterile pipette attached to my pipette gun and add 3 mLs of media to my flask. The media contains a protease inhibitor which deactivates the protease trypsin. Next, I'm going to label my flask and place it back into the incubator, making sure that the bottom plate is covered in my media mixture by placing it horizontal.
Okay. Hello. After this procedure that you just watched, cell splitting will occur. This happens when we deactivate the trypsin that broke down the cell's charges. First, you'll start by taking a sample with our large pipette guns and putting it into a microcentrifuge tube, roughly about 1.5 milliliters. Then you're going to take it over to the cell counter, where you're going to add Trypan Blue to fill in the dead cells. This program that we use will isolate the live ones from the dead ones, giving us a cell count value. Ideally, we're going to be looking for 2.5 times 10 to the 5th. This is going to be just enough for about 1 T25 flask, If you have an exponent of 6, that means you'll have to do the math, which will probably lead you to splitting 4 times. After that, if you do have 10 to the 6th, you'll distribute amongst the correctly corresponding flasks that you have, and then you will incubate each one. If you only have 10 to the 5th, like I said, you only stick with one.